Good morning, everybody. Thank you all for coming today. We hope you had a great time if you came to the book launch yesterday morning and that you enjoyed the welcome session and the motivation video from earlier this week. We have a couple of housekeeping notes while people are joining before we get started with the full presentation. First of all, we've resent participant IDs to everyone, so please keep that in your email safely so that you can complete all of the activities with that ID. When you are completing the activities, particularly the quizzes for each chapter, make sure that after the last question, you need to swipe to one last screen and click submit form so that your response is recorded. And recordings and slides for all the sessions will be shared after every session. So don't worry if you cannot join a session. We will make sure that the recordings are posted so you can view them at your convenience if for some reason you can't make it to the live presentation. We'll go ahead and get started in just right during the live sessions. The Q&A feature in Zoom will be the only way to send questions through to myself or whoever's the presenter. The chat will not be visible to me, I think. So if you just go ahead and type in the Q&A whenever something comes up, we will get to answering those around the end of the session. For these, we're going to run about 40 minutes of presentation and then save the last about 15 minutes for answering your all's questions. So please put stuff into the Q&A at any time during the presentation. And I'll either stop and answer questions live, or I'll hold them to the end of the presentation, depending on what is appropriate, and make sure to answer as many as we can in the time that we have allotted. So again, with that, thank you all for coming. It's a pleasure to see people here. And I will go ahead and get started with the presentation. This is, as you all know, the very first week, and this is the first live discussion and Q&A for the Development, Research, and Practice course. This is Chapter 1. Conducting reproducible, transparent, and credible research. I'm Benjamin Daniels. I'm a research fellow at Guide at Georgetown University and a data coordinator with the Development Impact Evaluation DIME Analytics group, as you all have met the group now. And I'll be presenting this chapter, and I'll also be presenting Chapter 7, unless anything on the agenda changes before then. So welcome to you all to the very first chapter. The motivation for this chapter, the reproducibility, transparency, and credibility theme, is that it really overarches the entire book and forms the kind of motivation and framework for how and why we decided to provide all these tools. Now, it goes without saying that high quality research should be reproducible, transparent, and credible, but what does that mean, and why does it provide a foundation for all of the work that we're going to do with data throughout the research process? What we want is that readers can understand that research is high quality through these ideas. We also believe that it makes it easier for you to do over time and projects if you implement these from the very beginning. So we start with this chapter so that over the course of data work, you can build with these ideas in mind. That way, without any extra effort from you, your readers can see and understand the quality of the underlying data, right? They can understand how that data corresponds to the study design that you wrote in advance and released potentially in advance. And they can easily reuse or modify data in code to test alternative hypotheses or modify it to other projects that they might have. Now, there's been a lot of discussion about what does research transparency mean, what does reproducibility mean in practice, and there's oftentimes a lot of fear that there's some kind of research quality police. Spoiler: there is not a research quality police. No one's going to come after you if your work isn't absolutely perfect. We really don't want you to think of it as though it's an extra chore and that it's being monitored by some other people and you have to perform to standards, right? Our goal is to look forward to open research. We want to be able to make our materials available without worrying about it. And doing this should actually make your work easier, right? If you're building from the beginning with the mindset that people should be able to easily pick up the pieces of my work and modify or adapt or change and understand them, then you should too. As your research gets towards its inevitable end, it always turns out that you need to go back and check something else, that you need to change something else, that you need to modify outputs or inputs. And if they're made to be modified and they're made to be picked up by other people, that makes it easier for future you, who we consider a perfect stranger, to do the same thing in your own work. So what does this mean in practice? For principal investigators or team leads, this means developing and documenting the research design and the corresponding data that will be needed to carry it out. Guiding the team in structuring and completing project registration and registration of any pre-plans that are made up in the course of the project. It means understanding the rights and responsibilities that may be legal or organizational governing data, code, and research outputs, including things like licensing and copyright. And determining for the team what kinds of methods of pre-commitment are appropriate, which you would have read about in the chapter and which I'll get into in a minute. For research assistants or research staff, what this means is actually putting these things into practice. So adjusting outputs and documentation to meet the technical requirements set forth by the team leads. Letting the leadership know whenever materials are ready to go, and also whenever they're not clear. Finally, learning best practices for reproducible and transparent research. Again, just one note for people who are just joining. I saw a hand raise. We won't be opening up any chat, so please just ask questions through the Q&A, and we will get to them either during the talk or at the end of the session as appropriate. So just type that in the Q&A function there in the chat. If you need any help with that, just post in the Slack, and they'll point out where that function is to you. So the first section here is developing a credible research project. So what does credibility mean? Credibility in the ultimate sense is very simple. It's an extension of trust. Can people believe that your design? Can people believe that your research faithfully presents your design, right? Now, you might say, well, of course it does. Everyone's going to trust me and believe me. All of the credibility of my work, of my findings, should come from the power of my research design. Was it intelligent and clever use of data and use of econometrics or whatever type of statistics or methods you're doing? This means a large sample size, a well-powered sample, that you have really believable treatment and counterfactual groups, that you have sampling and randomization that were designed well and carried out well. In the economics literature, which is my personal background, sometimes we call this effect identification if we're specifically talking about impact evaluation. It may have other names in other worlds, including things like causal inference is now a kind of cross-cutting name for this type of trustworthiness of design. But it turns out that lots of very small decisions regarding any design that you could possibly write down can change during research for pretty much any design as you would broadly define it. And so one method that we have developed for can we actually believe that your design is what we said it would be is commitment and proof. In case anyone is not familiar with Greek literature in Lego form, this is Odysseus chained to the mast passing the island of the Sirens. Odysseus knows that he cannot resist the call of the sirens and asks his crew to plug their ears so they can't hear the siren call and tie him to the mast so he can, but so that he cannot go back on his promise to not jump onto the island of the sirens. We want to do this in research in some sense. Again, you're not going to die on the island of the sirens, but we want to make sure that people will believe that you didn't change your mind during the work. So even in a very simple single research design, there'll be lots of flexibility in decision. I'll ask you about some of those things in just a moment. So think about what some of those decisions might be. Some of the obvious ones are defining outcome variables, which tend to be abstract ideas like poverty or empowerment or success, academic success, which are not things that we can typically look at directly and say, this is what it is. Which observations to include or exclude based on how the research went in practice. And finally, in terms of general statistical stuff, the kinds of functional form you might use, logistic or linear regressions, what controls might be included in a regression, and what kind of standard error corrections to use, which are famous in disciplines that are really serious about p equals 0.05, which you may or may not have encountered in your own work. So we provide, and the world provides now, a couple of methods of commitment to strategies and commitment to various degrees of specificity before undergoing the research, tying oneself to the mast in that sense. Now, registering research is the simplest one. Almost all journals require research to be registered. And at Dime, we require all research to be registered. This does not take anything. It doesn't commit you to much. All it says is, I tried this. It's free and easy in most registries, and you can expand it as you develop. And we expect that you should be able to pre-register, which means before you go to the field, just say, hey, we're going to do this experiment with this kind of general approach and this kind of general strategy without getting into high levels of specificity. So this is very easy and is now pretty much universally required and should not be a burden to anyone. Pre-analysis planning, so developing pre-analysis plans. Almost all research should have some form of pre-analysis plan. It's a bit of work to write it down formally, and these vary broadly in terms of the level of detail they go into. They can either, you can have a very slim pre-analysis plan that starts from, this is the data we're going to collect, this is the kind of intervention we're going to do if that's applicable, and this is the kind of statistics that we're going to run on it. And those can go all the way to the more advanced side, which is, these are the exact code we're going to use, these are the exact regression model we're going to use, these are the exact visualizations we're going to produce. So these can span a wide range. Every research project can have one, and the amount of effort can vary. And these can be published or posted on a third-party site. Often a registry will allow a place where you can post these plans. Again, it's not necessarily committing you to anything, but it's very good for the things that if you wrote it down and published it and you said, hey, we did this, no one can accuse you of having figured it out after the fact. Finally, registered reports, which is a pretty new brand of commitment mechanisms in the field. What this is typically is that it's a formal publication where you submit as a manuscript essentially a fully fleshed out pre-analysis plan. It gets peer reviewed and potentially accepted by the journal. And in most cases, this comes with a commitment from the journal to then publish results that follow that plan once you've collected the data and completed the research. So this is pretty new. Only a couple of papers have come out through this process. One of the suggested readings for this week was one of the papers at the Journal of Development Economics that has gone through this process, so we can see what it is and what that kind of paper looks like. And these are growing in popularity, especially for topics that may be controversial or have some expectation of finding null results, but are well-designed and well-powered. So we can make sure that those things are, which are interesting, but can sometimes be difficult to conceptualize and publish after the fact, are getting out there. So with the pre-commitment section, we want to have some discussion questions. I'll answer some of the quick Q&As right now from these. Reproducibility facts I'll hold for later. Credibility is registering research. Registering research is very different from getting an IRB approval to conduct a study. So IRB is only for the ethical things. Often these processes go hand in hand. You'll be writing out pretty detailed materials, but they won't be asking you for specifics about how you're gonna analyze the materials, right? You won't be saying to the IRB, this is what we'll include and exclude. This is how we're actually going to do the functional forms of the model. So there's a lot of the technical stuff that does not go to the IRB, since they're mainly concerned with the ethics. You'll generally want something else there. Feedback function. You can always give people materials. In Dime, for example, we have a process called concept note review, which is a World Bank wide process. When we're proposing something, we're very much circulating plans for feedback to peers. And there's no reason not to do that. We often get very helpful feedback from peers, and if you have ways to do that or mechanisms, most organizations will have a mechanism to do that, and you should absolutely do that. There won't be anything like randomly out there that you would get back. What's the difference between registration, writing a pre-analysis plan? If you write a pre-analysis plan, so registration is always needed. That's literally just putting your project name into a registry saying, we're going to do this project with this broad goals. Pre-analysis plan is a level of detail that could be included in a registration saying, this is exactly what we're going to do. Yeah. And the next question is an extension of that one, which is, yes, pre-analysis plans and register reports are very similar, but a register report is essentially submitting that to a journal and getting it peer reviewed and published with a potential commitment. So yeah, they're very similar in concept, but the practice is a lot more to get something through a formal publication. I'll hold a bit more for later and ask you guys some questions at this moment. So we want to ask kind of broadly what some strengths of pre-specification might be, since there's lots of questions about these. And while you all just go ahead and, if the instructions are out there, it's the same thing as before. It's the polev.com/dimeanalytic981. I don't know why those aren't displayed on the screen. Oh, it is there. And while you enter some strengths here, I'll answer a few more later. Does registration study apply to all forms of empirical research? I would think so, yes. I mean, various fields will vary in terms of how much they want you to do this. Impact evaluation, we definitely want to register, mainly because our things tend to be small, unique. They tend to have policy consequences, so people want to make sure that we have that credibility specifically. But we think that registration should be done for all forms of empirical. Again, it's very easy to register studies. Research can always be funded. Usually research is actually funded before registration. Otherwise you wouldn't have the project yet. This one. Is it a good idea for dissertation proposals to be registered reports? Definitely not. I mean, a registered report is going to be almost a full publication. So that's asking someone to get their stuff published. They should definitely be written up and registered and run done as pre-analysis plans. That's for Melba. These are great answers to strength of pre-specification. Yep, all of these are wonderful. So people have excellent ideas here. Now we're going to ask the other question. What are some reasons to value non-pre-specified results? So things that weren't written down in a pre-analysis plan or in a registered report. Flexibility, yes, that's wonderful. There's lots of things you may find out as you go through that will be interesting, relevant, more flexibility in execution. Exploration is another fantastic answer because we want to be able to address things that we discovered during the work. Fieldwork insights, fantastic. All right, so we get a lot of flexibility. So we generally get that. Yeah, these are very good. Very good. Cool. So these are all wonderful, and we'll move on to the next section with that, and I'll hold some more questions for the end. The second section here that we wanted to address was conducting research transparently. What we mean by conducting research transparently is something that ties directly back into this flexibility that we were just talking about when we're not pre-specifying results, which again is completely okay and is going to happen in every project out there. It is nothing to panic about and nothing to criticize, but we need to tell people what actually happened. The famous analogy from literature here is what we call the garden of forking paths, where there are many, many ways that something could turn out as a combination of all the decisions that have to get made during our projects. Our projects tend to be something like, I think the average development project from start to finish now is something like 7 years. So lots of decisions get made in those times. What we want to do is just be clear what was done. Namely, this is done through documentation. What observations were included in the analytical sample, which ones were dropped during field work, which ones turned out to be impossible to do, which might have been added as a result of stuff that we learned during the research in the field. How our treatment and counterfactual groups turned out. If we were doing an intervention, whether people took up the intervention, whether there were groups that had to be, that were not feasible to include in the actual treatment. Again, this is separately from the sampling and the observation, but in the implementation of any kind of project or policy that we might be working with. And then how final data sets and estimation models used in your manuscript or your policy report were finally implemented. Again, there's lots of choices in statistics, statistical modeling, and all of these combined may lead you down a very different route than if they had been done differently. Again, usually we don't expect that people, have their finger on the scale in some kind of nefarious way or are choosing these parameters to make a result that's not believable become statistically significant. We just want to write them down so that people can understand what we're actually presenting here. So we think about it in a sense of dealing with what ifs, right? We want to write down the reasons things happen so that people can understand why choices were taken and how to understand them, and why alternatives that they might have said, oh, this would have been, better for you to do. Why didn't you do this other thing, which I think would have been preferable? And you would say, well, it's because this happened and we had this deadline and we didn't have the time to do this, or this was totally impractical because of reaching this group of people turned out not to have working cell phone numbers. There's a million things in the field that will make you change plans. And again, that's completely fine. Changes to field work, it can be difficult, again, if this is a survey in particular, it may be difficult to reach people. People may have moved, sample listings may be out of date, designs may need to change for any number of practical reasons. And finally, we want to keep archive versions of things that we did halfway through to make sure that people can understand what things we tried when we were reevaluating. Methods for doing this turn out to be really important and really important to get right early in the project. When we talk about keeping a lab notebook, lots of disciplines, mainly what we think of as like hard science things, have a lab notebook. You write down everything you did, because one day you might say, hey, that thing that we did 3 months ago, what was that? We want to go back and make that kind of bigger, and we can't figure it out again necessarily from scratch, right? These decision points and these discarded things happen constantly in research. And all you need to do is write them down. The problem that we typically see is that people write them down in an email or in a SMS or in a WhatsApp, right? These are not lab notebooks, because if you've ever searched for an email from yesterday, let alone last year, let alone 5 years ago, you know that you are not going to find it. And if someone joins the email chain later and you forward it to them, how hard it is to read all those replies. Who's this person? What was that? Was this 7 years ago? It doesn't happen. You can't organize instant messages, and we think of email as an instant messaging service. So having a separate service that everyone agrees to, and we've provided some examples of ways to do this in the book, is essential to maintaining that documentation, being able to produce a record later. The next one, of course, is documentation of data sources and data contents. So this means a clear understanding, first of all, of what you have and how you're allowed to use and reuse it. Logs of data that was attempted to be collected, so we know what is incomplete, what is missing, what may be extra in case observations showed up that were unexpected in any type of data collection or transfer. And again, as a very basic feature, metadata, documentation about data, code books that tell us what variables are, how they were constructed, how they were collected, and archiving of original materials, meaning data that was actually collected in the field, instruments that were used to collect data, and other descriptions of data that are needed to understand and work with that material. So it's not, useless to other people. The last one, of course, is simply archiving the original data, being able to understand where to release that from, and being able to publish data processing, data construction, data cleaning, which we'll get to in chapters 5 and 6. So all of these can be organized well so that they can be released in the future, that they can be examined, that they can be changed if you want to see how something else might have gone differently on that garden of working paths. So some quick discussion questions. we talk a lot about p-hacking as a sense of what might happen if someone did this on purpose to say, I want to get that result significant. I'm going to do these little things, change the sample, change the specification, change the way I define the treatment group or the outcome variable. And there's a lot of concerns that results are p-hacked. If you read some of the extended literature, you might have seen this term a lot. So I'm going to ask you for your field. Again, I don't know where everyone is coming from, but what kind of proportion of results in your field do you think are p-hacked? And this can mean any level of manipulation to try and get our results to be just a little stronger so that we can get them into a journal, say. And let's say, let me be fair, I mean published results here. Obviously, unpublished results didn't make it. I'm glad nobody thinks 100% because that would be really disappointing or disheartening anyway to me over here. Okay, so some kind of, general consensus that there's a meaningful set of results that are p-hacked. Some people are saying something like 50%, 60 to 80%. We have some social psychologists in the field, it looks like. Yeah, there's no way to say, obviously. So there's no right answer to this question. And I'm sure if I ask again, how many of your published results are p-hacked, to be 0, 0, 0, 0, 0. So it's kind of this question of what choices are fair to make and what choices are not fair to make. So this next question isn't a judgment about what's fair and unfair, but what are some of the choices that maybe you would say are fine, or maybe they say wouldn't fine? What could be considered p-hacking in that sense? Yeah, controls, changing controls, changing the sample, changing the observations, excluding things, absolutely. Yeah, choosing which results to present. I see one in there, choosing which hypotheses to use after the fact, how to construct indicators. These are great answers. These everyone here is maybe too experienced. Some of these people could be teaching this class. Yeah, all of these choices that you can make, again, just as I said on the last question, any of these choices could be p-hacking, right? And it's very hard to show definitively that someone has done it. And if you're doing the research, you're almost certainly saying to yourself, well, I'm not p-hacking it, right? This is just a sensible way to do it. And obviously the big theme here is changing things. So the lesson here is twofold. You're going to change things. If you want to make sure that the way that you build that credibility by demonstrating that those changes that you have made are justified. So we write it down either in advance or when we do it, and then people, you have that sense to say, no, I wasn't p-hacking, right? These results are credible. So I'm going to move now to the final section in this chapter, which is analyzing data reproducibly and preparing a reproducibility package. So again, this all builds together, right? No matter what you've done in terms of pre-planning your project, and no matter what you've done in terms of publishing your pre-analysis, pre-commitments, you're publishing your plan saying, I'm going to do exactly this. And no matter what you've done in terms of saying, hey, we've documented all of the changes and all the decisions that had to be made during the field work and during the research process. And here's all the archive versions of the code and data, and here's our field logs. You're going to end up with this final product, which is, here are our final data, here are our final estimates, and here are our final results. This is what we want you to believe from our research. It is one of those forking paths. So what we need to do is make sure that people can now go in and explore what the other options might have been and say, hey, this is robust to other possibilities, other changes. So it means making our work accessible to everybody so that they don't have to come back to us and say, hey, what if you change this? You can do it yourself because I've set up the code and data so it's accessible to other people. Famous XKCD comics always make it into these slides. It means writing in a way that other people can figure it out. We do not want to see code ninja, insane stuff that is absolutely genius, but it would be impossible for someone else to figure out. We want to create very simple things that anyone can read, that anyone can use. Well-structured code that's split up and is not complex to figure out how to modify a section. README files that discuss how code is organized and how it relates to data. Those data code books that say, here's what is in each data set and how these different measures are related. If I have things that are called outcome 1, outcome 2, outcome 3, and don't have good labels and don't have good code books, how am I supposed to go back in there and say, oh, what if we used outcome 2 instead? Could be something completely different. All you have to do is write this down. Cleaning up temp files when you're doing complex coding is always helpful. And as with all reproducibility work, before you put that thing out there to the world, make sure it works for at least one other person. Someone hopefully outside your team, someone who's never heard of it and doesn't know what anything is, can click run and get it to you. At Dime Analytics conducts these kind of reproducibility checks for most of the Dime portfolio before we allow things to go into the working paper series. And that makes sure that the reproducibility packages that are required to come with our work work for other people when they go out into the world. And this has made a big difference. Again, the central theme is making your work accessible so people don't have to bother you about it, that they can do it on their own, that they're empowered to pick up your work and your research and carry it forward and do their own research on top of it, right? We're talking about open research, additive research, where we're a collaborative community all together, right? Another one of these things is making sure people know how they're allowed to use your work. We're not saying that things have to be fully published, open access to the whole world. Sometimes that's not possible. You have confidential data. You have data that's owned by private companies or by governments. You have things that can't necessarily be passed forward. That's all okay. We just want to make sure that whenever you are releasing code and data, which you should be planning to do, that you're clear about the licensing and legal structures of it, who's allowed to use it and for what, and if special permissions are required to share it with them, with other people, that those are clear where they might get it if they have to apply to a company or to a government organization to receive the data, which is true in many cases, that you simply tell them how. And that the documentation of that data, when it's yours, is provided, or if it's someone else's, that you point to it so people can go and find out how they're going to understand that data without, again, what's this variable? What's this mean? What's that? It should be laid out there and very easy. The second one is a clear documented progression from original data, the stuff that either you collected in the field or that was given to you by a partner or government, how you derived those abstract constructs, how you derived the treatment and control groups, how you derived the statistical and abstract concepts that are needed for that final research output. Otherwise, people are going to do, well, how did you invent this? How did you calculate this? We just put that out there. We just put together what we call the data cleaning and construction code. Again, we'll come back to that later. And finally, archival storage of your study materials with a third party when possible. Again, at the World Bank for data, we have the metadata catalog and the microdata catalog, excuse me. And for us, we have the development impact evaluations one. And for published materials, that varies. There's OpenICPSR, there's the OSF, there's various places where you can store. There's the Dataverses, of course, to store things that will be permanently available to people who want us to use them. So some quick requirements for these reproducibility packages that we're going to put out there. Obviously, they need to be accessible to others. It needs to run for other people, and it needs to run easily. There should be no more than one line of code that someone needs to change to set their local environment references, and then everything else should work if they have the right software. Software requirements are okay. You can say, look, this is Stata code. You need to have Stata to run it. That's still pretty predominant in the economics world. But we don't want to ask them that people also have MATLAB and also have the ability to read and write Mata code, and also minimal software requirements as much as possible. And the code should be structured and documented to be readable to what those are, right? I say edit here. I mean, edit your code like you would edit a document, like a written document. If someone else can't go through and read it and understand line by line what's happening, then it's not accessible. Yeah, so that's again really the core of what this is about. Great question here. When I say accessible, do I mean that it should be accessible to people with disabilities using script readers? I personally don't have a lot of experience with that, but you should certainly be writing, plain language comments in your code that would be that would show up and tell people what a specific line of code is going to do. Next one is that people can identify and change research decisions in code. So remember all those things that we wrote down about how did we construct our analytical approach to match our research design. This could be written down a million times. This could be written in your paper. This could be written in a manuscript. This could be written in a policy document. But if I can't go back to the analytical code and say, hey, this is where this is implemented, and this is the line I would need to change to make a different assumption or to use a different model, then it's not accessible. It's not available to me to say, hey, well, I want to change the standard errors in a different way, or I want to exclude this control, or I want to use this different measure. If I can't find that, change it, and run it just based on the comments and instruction of the code, is not accessible, right? And obviously the corollary of that is that the sections of the code themselves can be easily found. So when I see figure 5, I can either go to a figure5.do file, or I can find a comment that says, here is where figure 5 is made, and I can run that section without running anything else. So modular code becomes more accessible. You can go from the code to the output. You can go from the output to the code without any kind of, additional information. README documentations, plain language instructions, basically someone who has never seen this code before should be able to pick up the manuscript or the research output, match it to the code, and fully understand how they're related. So some discussion questions for this one. First one's a very simple yes or no one. Have you ever accessed somebody's reproducibility package before? Okay, so we have about 45%, not quite 50%, getting to yes. So that's actually pretty good. I haven't that says a lot about the take up of doing these in practice. And I know that the practice of using reproducibility packages for school assignments and stuff has become a lot more popular in recent years. So I hope a lot of people have interacted with that in graduate programs or even earlier. Because seeing other people's work is obviously fantastic. If you haven't, I hope you will. There's lots of materials out there. Dime puts all of our stuff on Git and GitHub, and we've included the entire package for the Demand for Safe Spaces project in this book. So if you are one of the no's, we hope that you'll access the reproducibility package for those materials and have a chance to see how we recommend those to be structured. For those who, whether you have or have not, what are some things that you personally want to see in someone else's reproducibility package? What makes that accessible to you? Obviously, give a lot of examples. Yes, code, absolutely. Data, that's right. The assumptions clear in the code. Comments. Methodology, scripts and do files. Comprehensive is a very good one that came up, which is, it really does need to show you the whole project. And if it doesn't do everything from start to finish, it's not reproducing the research. That's exactly right. Yeah, these are again all excellent researchers responses. Flowcharts, metadata, methodology nodes. Very, very good. Okay, so a couple of quick points on applying these lessons to your project. Again, to come back to that initial idea, Preparation across the whole team before you start working is going to save everyone a lot of time. You'll know what you're supposed to be doing, and you'll be working with that mindset about, okay, since this needs to be published and reproducible down the line, we're going to build it piece by piece to be reproducible the whole way through. And I promise this will save you a lot of frustration as you get towards putting a manuscript together, because you go back 6 months, 6 years to change something, it may not even be your work, it'll be a disaster. Have that research plan to follow, written down, some kind of pre-analysis plan, and update it whenever changes are made to the project for whatever reason. Have those versions of it keep going out so you can say, okay, here was the version 1, we changed this to version 2, we changed this to version 3. This can be very, again, micro level changes, small changes can be versioned. Complete the pre-research activities documenting those plans. Absolutely get the registration done, update the registration when you have new pre-analysis plans, put that out there so it's in a clear archive where people can access it. It's not in a folder buried on your hard drive somewhere, it's in a project repository. There are plenty of free ones out there. Know in advance how you are required to collect, store, and document data. This is about use and reuse permissions and the licenses that accompany them, particularly for data that you're getting from someone else or collecting in partnership with another organization, such as a company or government. Be prepared to communicate among your team. They will come back to this in the next chapter, and to preserve important communications, again, in a central archive that everyone can access and we know how it will be organized. And plan for reproducible and transparent structures. It's much more easy to build these in advance and say, okay, we know that this is always going to be our publishable one, which is our working copy. It's much easier to build that throughout the process of getting to the outputs than retrofitting it from your output. Say, we need to reorganize the whole thing. Now this is broken. Now this is broken. It's essentially starting from square one if you decide that we need to redo this at publication time. And it is a pain. So that is what we have. So thank you for coming for the lecture. Like I said, we'll reserve the last 15 minutes for answering Q&As. So please put anything in there now that I haven't got to. I'll start with a couple now. Is there desk rejection when it comes to register reports? There absolutely is. If you send, garbage to JDE, you will not get a response. They will, or that, they will send you, this isn't to the standards of the journal. We hope that you can improve it and resubmit it sometime. Chris is answering one for coding and program. There are lots of great resources out there to learn to code or program. If you're interested in causal inference work, we provide examples in our stuff as well. There's a new book out called Causal Inference, the mixtape, and there's accompanying courses for there. The author there, Scott Cunningham, is running Codecella, I think this summer, to learn how to do both Stata and R implementations of common statistical causal analysis research designs from economics. Can I share a good and bad example of a research plan? Unfortunately, you don't see a lot of bad examples out there because they don't tend to make it. We share good examples. There are research plans. I believe the one from the Demand for Safe Spaces project should be linked from the book. So find that box in chapter 1, and all the materials should be linked there. If that's hard to find, just ask in the channel chapter 1 Slack channel, and we will provide some links to you if they're not in the book, but they should all be. The handling of public and private data sets. Like I said, each data set is different. Public data sets are easy. They're already out there. You may or may not own them, so you may or may not be allowed to repost them, but you will, if you haven't seen Lars Vilhuber's talk on modern expectations for data citation, it's a great talk to watch. I'm pretty sure I've linked it from somewhere, but it's also easy to find. Cite the data, particularly if it is public and it's not something that you own and can re-release. That is often the case if it's a secondary use data set, such as US government census stuff. If it's a private data set, again, it depends what you mean by private. If another company owns it or another government owns it and they're not willing to re-release or republish it, again, you can cite it and provide clear instructions in a data availability statement saying that it was acquired from contact with such and such an organization, and that there's either an application process to obtain it or that they would have to contact directly to do it. Obviously, both of those comes with different responsibilities and permissions. You can't republish the stuff if you don't own it, right? Unless you have a specific license allowing you to do so. So have that conversation early if someone else is providing the data so that you know what those rights and responsibilities are. Do we have to follow the whole process for research using only secondary data? I mean, everything except for collecting the data, absolutely. Our materials here are supposed to be totally agnostic to the type of data you're using. And aside from the permissions, rights, responsibilities, and licenses that come with secondary data, pretty much everything is the same. You'll need to write down your plans, have your collaboration stuff, plan your research, which we'll get to in chapters 2 and 3, and then follow the steps for cleaning, constructing, and analyzing, just the same as you would with data you collected yourself. Can a reproducibility registration pre-analysis costs be incorporated in research funding requests? That would depend somewhat on the funder, but broadly, it should be construed as research time. So I wouldn't, I typically wouldn't be including these things as like a line item, but it's PI and RA time, particularly if it's something that becomes published, and most funders are requiring these things now. So I would say that wouldn't be an issue at all. If we are using a data set that hasn't been properly documented, well, how are you using it if it hasn't been documented? If you don't know what it is, you should spend some time, obviously, figuring out what it is and writing that documentation. So I would say no to the premise. You cannot be using a data set that isn't properly documented. You need to make that happen first. Writing clean code in R, there are lots of answers to that. There's a R style guide from Tidyverse and from Google. Louisa and others teach an excellent course on writing code in R, and those are available if you go to the DIME Analytics resources in Appendix B of the book. Researchers outside the US are not registering the project. I think people should generally be researching their project. It does not matter where we're talking about. If you're collaborating with researchers, I mean, again, your responsibility is for yourself. I'm not going to say, be out there getting on people's case about what they're doing or not doing. But in our case, research has to be registered in order to be published at most of the journals that we work with now. DIME enforces that, the AEA enforces that, and that is spreading. So if people are trying to get published, they're going to need to register their research. If they're not, then they can do whatever they want, right? If they're not trying to publish research, then you don't have to register the research, but you should be doing it, and you should be, for your own projects. It's not a costly or time-intensive process. Identifiable data needed in analysis is an excellent question. So there are, we still need to archive those materials in your private and secure locations. For us, it's the World Bank's, enterprise OneDrive system. Obviously, you can't release them. There are various schools have thought about how to handle spatial data is especially hard. You may need to make a restricted access data. It is possible to release that to people who will sign a non-disclosure agreement and receive that confidentiality. They'll promise not to use it for other purposes. They'll, give you their academic affiliation, have a letter from their thing, have an approved IRB to use the data already, right? So you can prepare what we call licensed access releases, which are non-public, but they are still published, right? We will still put that on the microdata catalog and have it archived in the World Bank system, but we would write a special terms of use that would require an explicit agreement to access identifiable data for reproducibility purposes. And then in our reproducibility package, we would just comment out that in the public one, we would comment that out if it was a map or something, say this figure can only be reproduced using identifiable data. To obtain the identifiable data, please access this microdata catalog entry and complete the licensing request with these requirements. So that's a great question and one that's coming up more and more as these become popular methods of statistical analysis. Who would be checking a published article? Just someone who's reading it. There's no pre-registration police and there's no reproducibility police. But if I was reading an article that said, here's the link to the pre-analysis plan, I'm just going to go over and say, okay, what parts of these were pre-registered? So I say, okay, for sure, this was set in stone before they had the data. So I can take that like with some extra credibility. And I can say, okay, so this stuff kind of came up during the research. Not that it's, made up or phony or anything like that. But maybe it's not just as credible. Again, there's lots of different things that go into it, but it's for the reader. Again, it's for accessibility. It's for credibility to say, okay, this is what was planned and this is what was not planned. Plenty of reasons to have both. So the reader is really who it is. And there's no police. There's no people coming to arrest you and take away your research license. Of course, unless you're being totally fraudulent and stuff, which is not even a question here. So yeah. Reproducibly open science movement towards null results. That's absolutely a big topic that's come up recently. But it's also one that comes up, especially with regards to the pre-analysis plans and some of those registered reports, which is, it can be hard to get null results published. I think everyone acknowledges that. And I think that varies from discipline to discipline, how serious that problem is. But broadly, part of the benefits of putting a pre-analysis plan out there, even if it's just on the project registration website, or doing a registered report if that's available to you, is to say, hey, look, this was a great project. You said you were interested in the answers. All these people said they were interested in the answers. And the answer is no. So don't throw any more money at this thing. People may get mad. Governments may get mad. They say my favorite policy does nothing, or worse, it's negative. From a research perspective, we should be indifferent to that. And we do want those things to get published because it is important finding, particularly if it's a well-powered design, a well-designed experiment on an important topic or an important policy. We absolutely want to get those things out there. It's not about our careers at the end of the day. What else? Where can an independent researcher register their research online? OSF has lots of links to registries. The AEA has materials. There's a social science one as well. There's a couple links in the book. So typically registrations don't go through the own institution, and there are lots of resources for that. We would link a couple in the book, but they tend to be discipline specific. So you'd have to find one that matches your particular field. Can you deviate from the pre-analysis plan? Absolutely, just write it down. If any issues, there will be issues that force you to change the design. Write them down, document them, have that documentation in a safe place, and be able to publish that, usually as an appendix or as an online supplement. Registered dissertation, you can. It should be, again, it's very easy to say, I'm looking at X, Y, and Z. There's no costs. There's no reason not to. And should we register the study when we're about to end the study? Yes, there's no time constraints on registering the study. And most places want the study to be registered in one form or another. It doesn't matter when you do it. Obviously, pre-registration is preferable and not difficult, since you're going to do the study and we're not asking you for details. But even if you haven't done it for some reason, or it's been some time, go ahead, put it online. It does help, and it creates it's searchable. It creates a place for you to link publications coming from it. It creates a place for you to link the data sets that are published and released from it. So it's really about creating that discoverable element. And again, because these registries are discipline specific, it specifically makes it easier for other people in your field to find your work. And that's really what registration is about, is making this stuff discoverable and easy to find the materials for. Does it mean a lot of additional work? We hope not. In fact, we hope that following these practices will make it less work, since these are things you have to do anyway. The whole idea in DIME analytics is making your work higher quality, but in a way that makes it easier for you to do the things that are going to be asked anyway. You will have to change your research. You will have to change your design. You will have to change your sampling. And it's kind of a classic thing, right? You have to put in more work at the time or up front, but our vision is that it saves you a lot of work repairing things later. Finally, I have one more here, and then we'll move on. Sorry to leave this one to last. Why is it important for a layman to understand the research practices? If you are, no matter who you are, decisions are made every day on research. Decisions about unemployment insurance during a pandemic. Decisions about how to, cure diseases, how to run schools. You don't have to understand all the research practices, but having a sense of what's credible research and what isn't makes a big difference with a lot of, nonsense and disinformation out there in some cases. So I think that's a great question as well. Knowledge management, I'll save for the publication chapter, which will be last, but yeah, this is about getting things out there. Data mining and specification searching, that's absolutely p-hacking. You shouldn't be doing those things with the intent of finding a particular result, right? Like getting things right is one thing, but we should not be, p-hacking is just redesigning the research for the intent of finding a particular result. And that's what's demonstrably like unethical. You should be getting it right, making sense, making things correct. So that's all I have in the Q&A right now. So unless we have another one, there's just a minute more, I will let us wrap up on time. I want to thank you all again. Chris has something, yeah.
No, while you've been presenting, there's actually been a lot of questions on data mining and specification searching and p-hacking. So if you can just repeat the definition.
Oh yeah, sure.
Of that.
Sure. So p-hacking, which is what, first of all, we want to avoid doing. I would never, say people are out to that, but we want to avoid being accused of doing it because it's very easy to do. There's lots of decisions that everyone faces. And what everyone wants to be able to say at the end of the day is, hey, the choices I made were made for the right reasons. It's kind of like The Bachelor. The choices were made for the right reasons to get the results correct. P-hacking is making those research choices for the purpose of finding a specific result, which is totally unethical and you should never be done. But it's very easy for someone to say, oh, isn't it convenient that the choices you made happened to get the result that you wanted? And you say, look, that's not why I made the choices. Each one was documented when I made it, independently from the rest, or they were all made in advance with no idea of what it would be. And if I'm lucky, I'm lucky. And if I change things, we can see if it's robust or not. And that's part of the making things accessible and alterable. But that's the big thing. There are so many changes. Obviously, from the poll, a lot of people here believe that there is a lot of that going on. And what we want to do is provide tools to for everyone to prove that their work isn't being done in this dishonest way. Again, it shouldn't be a lot of work because we're not asking you to make different decisions. We're just asking that you document and release the stuff that you do have and do it as early as possible to save yourself grief later and to help everyone around you say, oh, this person's research is trustworthy. That person's research is trustworthy. And building that's what open research is partly about, is that a mutual trust among researchers. So I hope that answers the question. And I think I'll end it with that because that is I think a good cap on what this chapter is all about and why that should underpin all of the work that we're going to do for the rest of the research project. So thank you again for coming. Again, there's no deadline on the quizzes until the end of the last week of the training. If for anyone who wasn't here earlier, we've resent the participant IDs. Please keep them and use them to fill out the quizzes. Swipe to the end of the quizzes, pass the last question, and click submit. Recordings and slides will be made and shared after every session. So if you missed part of it, or if you weren't able to join, we are going to send those out and send those links in the Slack and post them to the OSF. Everything will be fully available afterwards. So thank you again. I hope this was helpful. Welcome again to Chapter 1, and stick with us. The book is obviously wonderful, and we hope you all get a copy, a physical copy, as soon as they're in the mail. From Amazon if you've ordered them, and otherwise please enjoy the next readings for Chapter 2, which will be posted shortly. The link to the test will also be sent out again, I assume. Otherwise it'll be on the main materials on OSF with everything else. Thank you all very much. Everything's on the overview document.